We're live? Cool. Hello ladies and gentlemen, welcome back to the channel. Thank you so much for stopping by and welcome to our first video of our new series of making a game in collaboration with Code Like Me. So once again, if you want to see his work, if you want to see his game dev work, check his link in the description down below. And in this first video, what we're going to do is first I'm going to put my headphones and then we are going to create a landscape so we can glue all the characters, props and weapons and buildings that we'll do together. Now, as I said in the launch video, this will be a game inspired by real events, real people, real locations, and we've chosen the first Punic War between Rome and Carthage, and especially the city of Syracuse. So we're going to need a real world landscape for it, and I have a video about it, but it's outdated. You cannot do it this way anymore, so I'm going to, this is kind of a re-upload, but you know, we're going to go to Google and we're going to use Earth Data this time. Come on, Earth Data. And this is a very cool site. I think it's by NASA because it's nasa.gov website domain. So we're going to go to Data, Search Data, and once again we're going to use height fields. That is a DEM, which is digital elevation model, and then we're going to play with them inside Houdini until we get a good tileable terrain that we'll put inside the engine, test it out, and then send it to Code Like Me so he can do his things inside inside the game, and he will already have a landscape. So first thing, after you go to search data, you see this interface, and let me get rid of my face. There we go. And you go to instruments and you go to Aster, whatever it's called, however it's spelled. There you go, Aster. And now we're going to zoom right on Sicily because you cannot have Punic War without Sicily. We're going to get this piece here. We're not going to do the whole of Sicily because it's way too big for two people to do it. However, the cool thing about this is that you can always add more tiles after this because you're doing a tile terrain inside Unreal, and you can always make the world bigger with more tiles. So how you are going to approach this is you're going to one of those two tools you're going to use. One is the rectangular, one is the polygon. I'm just going to use the rectangular and select like this or something. And you see I have 29 matching collections, and I'm going to scroll down until I get Aster Global Digital Elevation Model version 003. And now it will find me 4 granules. Now each granule is a height map, and if you can see properly, the city of Syracuse, which is this little piece here, it is right in the middle of those two maps. So if I want bigger piece that is not just contained in one of those height fields, I would have to combine the height fields. Now you can do this in Photoshop, however it's a 16-bit grayscale pictures. Sometimes Photoshop doesn't handle them very well. You have to auto tone them to tone fix them, and even the smallest difficulty, even the smallest mistake will result in kind of a large difficulty difference. Why I'm saying difficulty so much? A difference in terms of the elevation, because it's very precise. So what we're going to do is we're going to download all those, and we're going to do all the tiling inside Houdini. So download those maps, just hit those here, and then once you download them, let's move to Houdini and I will show you how I created the terrain that you saw in the thumbnail. Alright, we're in Houdini and this is our final terrain. This is Syracuse and the vicinity of Syracuse, and this right here, whoa, come on, this right here is where the city will be. So I'm not going to build it real time simply because there are a few nodes that are kind of taking their toll on my computer. Even though it's a decent computer, it's still chugging at some point. But I'm going to go ahead and explain everything that we did. This is just a grid filled with blue color to represent water, and this is the node that we're going to take a look at. Let's ghost the water first. There we go. So now we can see better. Now don't worry if it looks too much. I will, once I explain it, it will make sense. But first, let me get back in the screen. That's too much. That's right. That should do it. Okay, so now first we're going to take a look at the real world terrain because I added some additions to it. And it starts here. Now what I did was we have the 4 tiles, right? And those 4 tiles, if you are those here that I've downloaded. When you open the zip file, you will have a DEM and a NUM file. We need DEM and they're numbered, as you can see, N3 through N36 East 14 and so forth and so forth. And what I did was I put them here using the HF file. There you go. And from here, I just hit this button. I got to a job folder or whatever they are and just put them in. You can just disable this because otherwise you might see them as 1 because they are kind of the name of the file takes enumeration, so you might not see them. So just disable this, load them, and once I did all 4 of them, there they are. I used all the default settings with the only difference that I used a 500 on the height scale, otherwise they're almost completely flat. We're talking about coastline, so except for this plateau or whatever, they're very flat. And if I load them, you can see that, let's disable the war for now. You can see that they are all on top of each other and they're not tiled at all, right? So what I did is I tiled them by using transform nodes. So let's mark everything that we've already gone through with this reddish color. So now blue. So once I had all of them and they're on top of each other, what I did was the first one I used the transform node just to keep it clean, and I did nothing on the transform node. But on the next, I moved it the corresponding 1000 units into the direction that I needed it, and I moved this one here and this one here. And if you see on one node I have a 1, right? That's because when I scale it up, I got a little bit of a tiling error, and that's just I put a 1 to figure that error and to solve it. So that's gone through, and then I merge them, and with the merge it will take just a second. There you go. With the merge there is nothing to say about it. You just go and type merge and you get the merge, and as you can see it's very heavy right now. There are some lines you can see, however don't worry, when we project them it will all go away. So then we go to the projection, which is the actual game terrain, and the actual game terrain is 1 height field instead of 4. Just once again the regular settings. The only thing I did was I used the grid spacing of 0.4, and what this does is the smaller this value is, the more details your terrain will have. By default I think it comes with grid spacing of 2, so I reduced this to grid spacing of 0.4 so I can get better details. And then I used another transform, but this time I used a height field transform. And to get this node, you can get HF transform. It's a height field node, while these were just the regular transform nodes. So with this node, what I did was I rotated it so Syracuse can be on the east side of the map, otherwise it was not. I nudged it into the position that I wanted. I uniformly scaled it by 5. The difference between those is that the uniform scale scales height as well, while the grid scale just scales it into the X and the Z, and it stretches it so it doesn't scale it up in Y, which you don't want. And then I did a height scale of excuse me, of 1.8 8 because I knew that I would use a lot of erosion, and the erosion takes a lot of the height. So I decided to like over crank it a little bit just so I can scale it down with the erosion and still get a good terrain similar to reality. And then once again, I told you I nudged it into the position of the height field. So basically what we're doing is let me see if I can do it like this. If I select this one, come on, wow, there we go. And then I turn this as a template. Yeah, you can kind of see that this here is my whole game terrain, and the map is like 1/4 of Sicily or something, right? It's huge, the height field, and the game map would take only place where the city of Syracuse is. And then I projected those. So the project node is come on, man. That's what I mean, that sometimes Houdini can get a little bit of a chugging operations, but from here on it shouldn't be a problem because we are not dealing with big files anymore. So now this is the game terrain project. You plug the height field on the first node, then you plug the projection on second, and you project it, and that's for the projection. And then because then the ocean floor, because the height field, that's the way they work when there is something below sea level. The files that we downloaded from Earth data, they show it completely black, so it's like absolute flat, as you can see. And I didn't want that because I can always sculpt it later in Unreal, and probably will if we decide to have some kind of underwater mechanics like swimming underwater and searching for treasures, whatever. But for now, I just didn't want to send it to Unreal with completely flat ocean floor. So what I did was I drew a mask by features from the terrain, and with this mask, what I did was I made it the mask to mask by height, and I computed the range, and I brought the max height to just 0.001, so like the smallest iteration that I can get above 0, and then I completely blasted the slope, the ramp, and that way I get only the lowest level of the map, which is the height map. As you can see, it's a little bit like pixelated, and for that I use the mask blur. First I used the mask blur, but I used it to shrink the mask. So I shrank it by 2, just so when I blur it, I don't get this side here. I only get what the actual ocean floor is, and I just blur it from the point of where the coast is down to the ocean. And that's why I use another blur here, which, as you can see, it has pretty much the same radius, one more, and it's a box blur. You can play for your game, for your landscape, until you get the desired effect. And once I did this, I used the noise with this mask put in, and this noise is, as you can see, amplitude and element size, and it's very, very small effect. However, it's not completely flat. Have in mind that this is a big terrain. This will be an 8K terrain inside Unreal, which even the smallest kind of bubbling, kind of wobbles in the terrain will represent some height difference. And then I just clear the mask, and that's how I did the ocean floor. And we move next on to the details. Now the details, what I call details, is the erosion pass. And what I did was I blurred I blurred the terrain. And by blurred the terrain, I mean I just blurred the terrain from the ocean up, because I don't have too much details on the ocean floor with the things that we just talked about. I didn't need it to blur it and further decrease them. However, when you go through these Earth data height field maps, sometimes you get a lot of this, which is cool. However, sometimes they are too much noisy. It's too much noise for you. So what I did was I put up a mask right from the very projection. So this mask, as you can see, goes out of the projection node, and in it I did the same thing. However, I just disabled the invert mask. So if I click it, you will see that it basically does the same thing. However, it encapsulates the terrain from the very bare minimum up, and not the other way around. And then, as I told you, I blurred it a little bit, and then I ran on a road, which a road is a little bit kind of a stranger road, this one, because it's it doesn't have any hydro erosion. It's just a thermal erosion. Because the hydro erosion I don't want, I already have like rivers and stuff like this. I just wanted to bring down this unnatural like these peaks that are, although they are good, I don't really find them appealing. So I ran an erosion with erodibility of 1, and I cranked up the erosion rate to 1, or 0.994 in this case, of the thermal erosion. And then, as you can see, it just smoothed those big kind of unnecessary peaks on top. So if you see all those here, it made them more natural, more nice. And from then I ran another blur just to get a little bit off, because I found that here there was a lot of debris from the erosion, those things that I didn't like, so I just blurred them just a little bit. And I knew I would run another erosion eventually, so I didn't worry too much about that. And if I ghost my river again, my ocean again, you can see that I still didn't lose any of the surface around the city, which was the most important to me. In any case, there is going to be another pass of this terrain inside Unreal, like sculpting with brushes and alphas or whatever, or even we can move to a second iteration of inside Houdini. But to get started, I was happy with what I had, and that's the Earth data terrain. And from then on, this one here is where I got these hills, because if you see this one, it's very flat, right? And I know it's not what I'll do here is kind of taking away from the authenticity of the terrain. However, with big world terrain, with a big open game world, the thing that you must guard the most against is repeatability, and the feeling when the player plays the game that the whole world is basically the same and procedurally created. And while we are procedurally creating a lot, we can still have diversity, and that's why I created those hill areas here, just so we can have different almost biomes. We can have like a coastline here, we can have like a different type of coastline, like a rocky coastline or sandy beaches. Here we can have like the big plateau mountain in the back, and now we have like hillside and perhaps some marshes or whatever. Just this thing gives us the ability to make a more diverse terrain, and I'm going to show you how I did this. It's basically a height field. Let's ghost it again. Let's hide it again. Yeah, it's basically a height field, then a noise. The noise was I did a noise that I thought was would blend together well, and from here I did an erosion pass. Right, once again a small erosion pass, a blur, and after that I layered it with the height field. However, I drew masks only on the places that I wanted, on those hills, right? So I drew a mask, and then I blurred the mask a little bit. I mean, this time I blurred it, well, not just a little bit, but I blurred it enough. And then I layered it together, like the terrain and the hills that I created with the mask. Like otherwise, it would have like created everything, messed up my whole terrain and not just the place I wanted. And I did a blend of 0.624, whatever, layers height and maximum strength. That's pretty much all I've changed. The other things are basically normal, and I think that's it. And now all we have to do, and this is my final terrain we're going to use in the game, all we have to do now is to create an output. And I left this part for live, so just so we can kind of do it together. What we're going to do, let's get rid of this that I've already had. Let's type HF output. There's a high field output. We're going to connect it, and we're going to use this to get our tile maps. So first things first, I go to my job folder. I'll go in our folder called tiles, and we're going to call it Syracuse. I cannot type today, I don't know why. .png. We're going to use pack raster. We're going to go for single channel, 16-bit fixed, and we're going to override the resolution to what we want. Now this is important. Let's see. There is a document called UE Technical Landscape Guide that talks all about the resolution and components, and I'll pull it up in just a second. We're not going to have any animation. I've run the erosions, everything I've run for 8 frames. We don't want those, and so we don't need frame range. We're going to select the height. That's pretty much the most important thing. Select height. We go, and another important thing is auto remap it from 0 to 1, and then divide by tiles. Now this here, I am not going to give you an exact size just because there is none. You gotta test it and try it and test it again. One thing I'm going to tell is that you need the XY tile. Yep. And then another thing, we're going to do a 1 tile overlap. That's tile overlap by 1 means that they will overlap very slightly. Otherwise you might get some kind of like errors when you put them together. If you're using world machine, for example, this is set to 0.1. However, here we can work only at integer value, so we're going to put 1. And now this thing here is completely tied to this here, the resolution. And if I get this document that I talked about, Unreal doesn't want to load today. Anyway, I know that 29 by 8129 is the resolution I want. That's because I tested it a couple of times and I decided that I'm either going to 4K or 8K terrain. So where was I? Yeah, so if you know the exact resolution, if you're working in a team, they should be given to you by your technical artist or something. You can just go to number of tiles and create them. So number of tiles this is the side of X and Y. So basically, if you have 8 by 8, you would get 16 tiles. No, you'll get like 64. What am I talking about? Yeah, this is it. It loads some kind of stupid way, but anyway, it doesn't matter if it's a little bit hard on the eye at this point. I don't know why it loads like this, but here you have recommended landscape sizes and you have the different resolutions. And as you can see, like when I say a 4K terrain, it's 4033 by 4033. That's not like a regular 4K resolution when we talk like textures and stuff like this. However, Unreal just have these different types of measurement that works best, and it's recommended. It's not by no means mandatory. It's just the best the engine handles. So I'm going for this, the biggest range, and I am going to go for a 8x8. Let's try this and see how it does it. And now what I can do is I can save to disk. And now this will take a little bit because it's, well, a big terrain. I tried it with a specified resolution, not just the number of tiles. It works as well. However, it's I get an extra row of polygons of tiles that has like almost no terrain to it. Probably because I used. Let me get back the screen with the numbers. I tried to do an 8K terrain divided on 4x4 tiles of this thing here, right? So of 8x8. However, I didn't get it just enough, so it created an extra range of like an extra X and Y strip, which then I had to delete inside the engine. So we're going to try with number of tiles instead of tile resolution. We're going to see how we're doing. If I bring the small window, there you go. You can see it's compositing them, and it will take like a minute or so. Once again, it's a big terrain. But I will be with you once this is done, and we can test inside the engine. Cool, the last thing we're going to do today is bring this whole thing inside the engine and see if we got the details right. So I have the third person template open, and let's just make another level. So file, new level, whatever, the default one, and like to have a tiled landscape, we gotta enable the world composition. Enable world composition. Oh yeah, it's gonna tell us that we gotta save the level first. So save current. We're gonna go to maps, call it Syracuse. There we go. Now we have Syracuse, and now we can enable the world comp. Yeah, sure. All right. Now we have this, and we can add from levels, import tiled landscape, and you have a couple of things you gotta know if you want to add the material. If you have a landscape material now, just add it from here, right? If not, just go to select heightmaps, and it will give you the game folder. So you gotta navigate to your Houdini folder or the Houdini project, and in the tiles, there they are. So we can now test and see how it goes. So just select all, open, because it's kind of important to keep the flip tile Y component coordinate. And now you're gonna import it and wait for it to be done with it. It will start importing all the files, and once it's done, you will have your tiled landscape. As you can see, inside the persistent level, we have all the tiles that we created, and if we load all of them, it will just load all of them for a second. Let's go to 0.28 of the camera. Check it out. That's our world. Now, if you open this one, yeah, the world compositor, you will see. Come on, dude. Oh, you don't wanna. Okay, you will see that it's very not much centered, right? So we can fix that by just moving it where we want it to be, like here, here. Yep, and it will take a second to move. And now we have our terrain. Now one thing I want to do very quick, because it bugs me, it's the auto exposure. Get out of here. There we go. Now this, as I said, we have this problem with the terrain being very close to the ocean bottom, so probably we'll have to fix that in a future video. However, as you can see, we have where the city will be. And now don't look at this. This is a very huge terrain. So if let's see, in the world outline now, have player style, we're gonna delete this. Something else, we gotta delete the floor. So let's get another player start and put it here, and you can see how small it is compared to our terrain. So basically, hit play. As you can see, it's very, very small. So if we run up, now let's check how it looks with water. So what can we do to fix that? We can make a plane, right? Because we haven't added any water yet. And we can 0, 0, and then just make it a huge. Right? And now we can bring it down, because right now, if we zoom out, it is above everything, so we can bring it down. So right now we can bring it down a little bit, something like this. And you know what? Just to test it, I'm going to water map very quickly. I can just apply it. Now we see that we have our water. Now, an interesting thing is that, like, this is a game design point of view, obviously. However, if we gotta move fast, let's try. Now, when we go through here, we don't want to fall from the edge of the world, right? So basically what we can do, and this will be featured more, what we can do is we can make the playable world to be, I would say like up until this point somewhere here, and this could be filled with distant meshes, right? So we can cheat the player into thinking that the world is much bigger than it is. Yeah, so let's play. That's it with our terrain. In the next video of this series, we are going to start and take a look at the center figure of our project, the main character. So stay tuned, and I'll see you then.